Welcome to the first episode of the Ada Lovelace Day podcast. My name is Sue Charman Anderson, and in this podcast I'm going to be highlighting the work of women in science, technology, engineering and maths, collectively known as STEM. I'll be talking to women from around the STEM world about their careers, as well as talking to women and men about historic and modern women's achievements, discoveries and inventions. This is the first in our ongoing series of podcasts, which is made possible in part by the generous support of ARM, our exclusive semiconductor industry sponsor. This month, we're talking to Dr Helen Czerski from University College London about her work as a bubble physicist and about life on board a research ship. And we'll hear from technology journalist Clive Thompson about Canadian metallurgist and research physicist Ursula Franklin, who's perhaps most famous for her social and political critique of modern technology. So I'm joined today by Dr Helen Czerski, a physicist at University College London. Hello, Helen.
Hello.
How are you doing today?
I am doing well. It's been a busy day, but it's been interesting, so that's all right.
Excellent. So, tell me a little bit about why your day's been interesting. What is it that you do and what's caught your eye today?
I have a job. So I'm a physicist, but I study the ocean and I do all that in an engineering department. So inevitably studying something as complicated as the ocean means that lots of different little bits and pieces come into play. So it's not just that I can do physics and only physics. I have to worry about chemistry and occasionally biology and acoustics and optics and how to build instruments and all these other little things. And so my day has been quite varied because I've been talking to a student in the lab about how to do a bubble experiment. I've been looking at data from time we spent on a ship a few months ago. I have been planning future trips to the ocean. And I've been doing logistics and worrying about how I'm going to organise my week, which takes up slightly too much of my time. So it's varied. Most of my days are quite varied.
This seems like very much a cross-discipline area that you're working in. I mean, we do have a tendency to think that a physicist works maybe with the Large Hadron Collider and deals with lots of data, but actually your job as a physicist is far broader than that.
One of the problems I think we have with the image of physics is that we as physicists, and it's a sort of collective responsibility, have done a great job of making it look to the world as though physics is only cosmology and quantum mechanics. And actually most working physicists are in the middle. And there's this kind of spectrum, if you like, from quantum, which is very small and very weird, and that's very, and then you get a bit bigger and you get into the middle where I work, where it's all classical physics. But it's messy because you've got lots of little things doing things and interacting, but it's all classical physics. And then you get bigger than that, and then you're sort of off in the scale of the universe, and it's all about elegance and elegant theories of how where the universe came from and what it looks like now and all that kind of thing. And so I think those two ends of the spectrum, the quantum and the cosmology, are obviously important, and they do excite people about physics. However, that is not all of physics. A lot of the most interesting physics being done right now is this messy bit in the middle. And the reason I like it is, first of all, you can see it. I study the bubbles underneath breaking waves, and I can see them. I can swim in them. I can stick my hand into them. I can't. They're doing things slightly too quickly for me to really follow just, with the sensors that are built into my body. But they're right there and they matter in the real world. And I think we don't talk enough about this branch of physics which is here. It's complicated and messy, but it's very real and it tends to get neglected. So I do that bit. And by its nature, that is very multidisciplinary. And so, which is great. You need people who have certain specialisms. And my specialism is physics, and in particular, the physics of the very small and the very fast. But that means I need to plug into a system. I need someone who understands chemistry well. I need someone who understands how to build optical instruments. I need someone who understands how to measure and quantify the weather. And so it's this business of dealing with this business of dealing in the world of the messy means that you learn about a lot of other things as well. You have your expertise, but you plug into this jigsaw puzzle of lots of different areas of science.
you mentioned that, bubbles are important. What is it about bubbles that they need this level of study?
Bubbles are the workhorses of the physical world, and that we either don't see them or we ignore them because we think they're kind of trivial and things that children play with. Anything that turns up in the bath is unlikely to be taken seriously in my experience. But there's a lot of valid science there, and the reason that bubbles are interesting is that they are this mixture of two phases. There's a gas trapped inside a liquid. I don't deal with soap bubbles. I study bubbles that are air bubbles in water in the ocean, and the bubbles I'm interested in are underwater bubbles, so they're gas bubbles surrounded by liquid. And the really important point about bubbles is that they are surrounded by a surface. There's a place where the gas and the liquid meet. And that interface, the place where the gas and the liquid touch, has all kinds of very useful properties. It's different to just gas or just liquid. And then the bubbles are very good at exchanging things between the inside and the outside. So a bubble that's been in water for a while won't have the same stuff on the inside of it. Some of the original gas will have gone into the water, and some other stuff that was in the water may have gone into the gas. And so they're also vehicles. And then finally, when they rise to the surface, and you see this very commonly, if you lift a fizzy drink up to your nose, you'll feel it spitting tiny particles up your nose. And so the bubbles are also spitting little blobs of liquid out into the atmosphere. And those turn out to be important in lots of situations. They're called aerosols. They change the taste of champagne. They change how clouds form. They change what can go through the atmosphere. And so bubbles, because they're at this, they start off as being this odd mixture of a gas and a liquid that don't want to mix together. It makes them very useful for doing things. So we use them for doing things all over the place in our society, but we tend not to see them.
So this sounds like this requires a lot of attention to detail and a lot of cross-disciplinary knowledge. I mean, what kind of qualities do you think you bring to your job that make you successful?
I am a weird mixture of a stickler for detail and very good at broad brushstrokes estimation, I guess, which is the training of any physicist. So I do have a very specific expertise. I'm trained as a physicist, and that gives me a very strong foundation when it comes to understanding how the physical world works. And also I've got years of experience of working in this field, so I've dealt with lots of data. So I do have specific expertise. But to combine that with the real world, you also need an interest in the way the rest of the system works, I think. So I'm quite pernickety when it comes to detail, and I know I'm quite picky when it comes to testing. I don't take anyone's word for it. I think to be a scientist, certainly a research scientist, you do need to be a bit of an awkward sod in the case that you've got to be really persistent and not sort of give up when problems come along. And problems come along all the time, so that just becomes a state of mind. But you've also got to have absolute integrity. You've got to not take anyone's word for it. You've got to look at the data and go, does this actually demonstrate what you think it does? And not just does it agree with what you already think, but how could your idea be falsified? Like, if this thing is true, if this is a good model for the world, what prediction does it make that we can test? And so you've got to be quite pernickety in a way about, you've got to have absolute integrity when it comes to whether the science is right or not. There's no cutting corners. The physical world is the way it is, and it's your job to find that out. So you have to be testing yourself all the time and have very high standards for testing yourself. Having said that, that's only half the job. So about half the job really is really concentrating on numbers and taking in information from papers and trying to synthesize ideas. And then the other half is just you've got to be able to collect your data, right? And inevitably, that involves quite a lot of creativity. How are you going to build an experiment? How are you going to solve this problem with the tools that you've got? But it also takes a reasonable amount of patience because data's difficult. Experiments never work first time, and so you need to be persistent with it. So there's this weird combination, I think, for science, which is sort of stubbornness and just being interested. I mean, you've got to have the sort of mentality that pokes at things. It doesn't just sit back and go, oh, there it is. You've got to what's that doing? What happens if I do this? It's the sort of a thing about interrogating the world. So you do need to have sort of stubbornness and persistence, but along with that, there's a lot of creativity, because the physical world only gives you so many tools, right? You've got Newton's laws, and you've got, how fluid dynamics works, and you've got the chemicals that are available from the periodic table, and you've got to solve a problem using these physical tools. And so you do need creativity, because you've got to dream up solutions. So it is a huge mixture of things. And of course you work with other people. Oceanography is a very sociable discipline, because everyone's worked on ships with other people. I often thought, I've never done this study, but there's that thing about the 6 degrees of separation, that if you can link people, you can link yourself to a movie star or someone through someone who knows someone who knows someone. Well, I think in oceanography, if you did that via who'd been on a ship with somebody else, so, I've been on a ship with this researcher, and this researcher's been on a ship with that researcher, you could probably link every single oceanographer in the world in 2 steps. That would be my guess. So it is, you have to work with people, and it is a relatively close-knit community, because ship time is very precious, and the time you spend on the ship is very valuable, and there tend to be more than one group of scientists on the ship. I mean, one of the other things about science, I think, is that because of the freedom you have in science to define your own job, you also evolve towards the sort of thing that suits you. So if you like teamwork, you will seek funding for projects which involve lots of teamwork. If you like theoretical models and lots of digging about in really big data sets, you will choose that area of science. So I think after a while, every scientist's field starts to reflect their personality, because science gives you the freedom to do that.
And I think as well, there is such a vast array of different types of science job, and that require different qualities and have different ways of working.
Yeah, and there's more to life. There's more to being a scientist than a research scientist. So when people think of scientists, they often think of people who do what I do, which is I work out that there's something that we don't know about how the world works, and then I go and poke at things and to find out what that thing is. But actually, that's only one branch of the people who are called scientists. There's lots of people who are using science, or they're solving more specific problems. So their problem isn't how does the world work in general, but how do I get this piece of fluid dynamics to work in this situation? How do I use it in this situation? And those people can work in industry, or for government, lots of places where they are doing science, and especially where they're synthesizing information. They need scientific knowledge to understand how the pieces come together, but they then write a report or a review or make recommendations or advise, and they are scientists as well. They're not at what is traditionally seen as the coal face, but they are synthesizing ideas and making them useful to society. And so there's lots of types of scientists, and it's not just the type who do what I do.
And tell us a little bit about life on board ship, because you've mentioned that you go out on these expeditions and you study bubbles, and part of me is kind of thinking, what do you kind of dive in? Do you chuck equipment overboard and it does it for you? How does that work?
Sadly, I'm not usually allowed to dive in. If we're doing coastal work, I have, but off big research ships, you're not allowed to. So normally on a research ship, you go to sea, it's usually for at least a month, and that's just because, first of all, it takes ships a long time to get anywhere. So once you've got there, you want to stay there and do stuff. But secondly, because a lot of what I do deals with, all oceanography depends on weather conditions and ocean conditions. And so sometimes you have to sit and wait for a couple of days until the storm turns up, in my case, or the storm goes away if you're doing ocean drilling. So you're dependent on conditions. And so you are usually at sea for a month to make sure you get the conditions you need, either storms or calm or whatever it is, because the ocean doesn't, sadly, it doesn't obey written instructions. And so you have to wait until the right conditions come along. So what I do is study how the ocean breathes effectively. The reason that I'm interested in the bubbles underneath breaking waves is to understand how gases of different types cross the ocean surface, oxygen and nitrogen or carbon dioxide, and how gases go the other way, and also how tiny particles, these aerosols, are spat up from the ocean surface. And seafarers have looked for centuries out at horribly stormy seas, and they've seen these great crashing waves and the white foam on top and the terrible windy conditions and the surface of the ocean blowing away. But almost no one has looked just 2 meters underneath, and that's where I'm interested. So fortunately, because I study storms, because that's where a lot of there's lots of breaking waves, there's lots of mixing, there's lots of breathing going on. I don't have to get into the ocean, which suits me just fine. And even though I'm a very active outdoor person, these seas are not somewhere a human should ever be. But I usually have a buoy, so a floating platform of some sort, and we do indeed chuck it overboard. It'll have batteries, it'll have various types of measurement down it, and we'll let it float free in the storm or whatever conditions we're studying. And then after a day or a few days, we go to where it is and fish it out, download all the data, recharge the batteries, and chuck it out again. So it's interesting because I can see the ocean surface, but I can't see what's happening just underneath. But I do have these devices, both acoustical devices and optical devices. So using light and sound and anything else I can get my paws on to tell me what's going on directly underneath the surface. So it's very it's quite hard physical work quite a lot of the time. It depends on what's going on. Because I study storms, I have worked in very big seas, sort of 7 meter, 10 meter average swell height, for example, which is big in a big storm. And you're living on board ship with maybe 20 other scientists, maybe 20 crew, depends on the ship. And so you're a little floating village. You take everything with you for a month or 2 months or however long it is, and everything is on board. There's a mess deck, there's a kitchen where you all eat. There are staterooms, which are cabins where you sleep. There's a lab space. There's usually a TV room. There's a gym. I spend an hour a day doing exercise of some sort because otherwise I go mad. And you do adapt to your little village surprisingly quickly. And you get used to it. I do quite like living on ships. I thought I would hate it because I'm a fidget. I like the outdoors. I like space and freedom, and the thought of being cooped up in a glorified tin can really, you wouldn't have said that was my kind of thing. But humans are really interesting in their social reaction to things, and people sort of shrink down their expectations on a ship, and most people are absolutely fine with it. So you live in your little tin can for a month, and then you see land sometime.
I think that the sound of life on board ship, it sounds like something that could be really quite challenging, but you seem to thrive off that. What are the sort of roadblocks, the bumps that you face where you kind of think, right, I really need to figure out how to deal with this?
I am a compulsive opportunity taker in a lot of ways, and so I get myself into a lot of situations where I don't know what I'm doing and I don't know how to do it because I just went, oh yeah, I can do that. Within reason. But if someone says, can you design a buoy that does this? I'll go, yeah, I can do that. I know I can always ask for help, right? But I'll say yes first and worry about exactly how I'm going to do it afterwards. That is a feature of things. And so the challenges, I guess, are, that they're sort of folded into that, in that that's a fun thing. You say, oh, I've never done that. Of course I'll have a go. And then you work out how to do it afterwards. And as long as you're intelligent and you're honest about how you learn and when you need to ask for help, then people can learn to do things. So I think a large part of it is not holding yourself back. I think the biggest challenge most people face when they turn up in a situation like that is that they hold themselves back. They go, oh, I don't know what to do. I don't know, I don't know who to ask, or maybe I'm not very good at this. And instead, the way to deal with it is just to meet it head on and go, right, okay, I don't know how to do this thing. Who here knows how to do that thing? Can I find someone or phone someone or, email someone who's going to tell me how to do the thing I can't do? So the challenges, as far as I'm concerned, are fun. Those sorts of challenges. The difficulties in what I do are often to do with the fact that if you're on a ship, you basically have one opportunity. You go for a month or whatever it is, and that overall will be, 2 years' work. By the time you've built the kit to go and shipped it to wherever you're going, and then joined the ship, and then done the stuff, and then analysed the data and written the papers, it's a long period of time. And at the heart of it, there's this 1 month period. And so the most difficult thing really is really making sure you make the most of that period. And that's the only bit I find stressful in a way. There's types of stress, but some types of stress, you can just work harder and you'll get it right in the end. But on the ship, if you don't get it right in the next half hour before you put the buoy overboard, you've got a problem. And that's just the case, you just have to accept that you do your best. Everyone understands these conditions are difficult. We're very data poor. Any data is valuable. So you absolutely do your best. And then you have to accept what you've got, which can be very frustrating because you go, oh, if that battery had just switched on when it was meant to, or if I just, set that thing better so it worked better, I'd have amazing data. But you have to deal with what you've got. So there's a frustration involved in the fact that it's a kind of one-shot thing until the next big cruise. But other than that, it's just willingness to learn, I think. And I think you have to find that fun. And I'm in this because I get to play with toys. I get to be outside in the outdoors environment. But fundamentally, the physical world is a toy box as well as a toolbox. And when you prod the world, you learn things. You can sit where you are and wait for things to come to you, and basically life will be predictable. But if you prod things and poke things, you'll see things you didn't expect, and that gives you new things to poke and prod and new toys to play with. And so it sort of feeds off itself, this continual looking for problems in a way. The mental difficulty, I think, that many oceanographers find is that it's never finished. I mean, maybe this is common to science, but you have to be very disciplined about when you've done enough, because there's always more. And you have to say, you know what, I've done however many hours work I've done today. I've spent 3 months writing this paper or whatever it is. And you know what, I'm going to stop. And it's really frustrating because you go, oh, I just did that. If I just did that, things would happen. But the problem is there's too many things already happening from all the other projects you've got on the go. So there does come a point where you have to go, it's okay to stop. And because we have journals, you've written it up, someone else can carry on.
It's very artistic in that sense. A work of art is never finished, it's just abandoned. Yeah. You have to figure out at what point you're happy to abandon something and say, right, this is as done as it's ever going to be.
Yeah, and the thing is as well that sometimes that's a good thing, because there's a law of diminishing returns. And if you publish a paper on something and it's got some holes, it may turn out that if you wait 3 years, somebody else will see a thing, and then you'll be able to put those two things together and then make the next step. So it's also part of science that you can't do everything at once. You put out what you've got, and then somebody else will have other things that plug into it. And then it may be you, or it may be somebody else that goes, oh, if we take these 3 things and put them together, then we get a new thing. So it may be that the law of diminishing returns is actually, you have to acknowledge that science is never finished. And so you have to do a proper job of what you've done, but it's okay that it's not finished, because the tools may not exist to finish it. So there's no point you banging your head against the wall, for months. If it turns out that you publish it, let it go, and a year later someone else goes, oh, I've just made a thing that could solve your problem. So it's that sort of thing. It's not being finished is part of science, but it's also what makes it exciting.
So talking of things being exciting, what are you excited about in terms of what's coming next for you?
I'm excited about finally finishing writing up the data from my last cruise. So I went to sea 2 years ago now, and I got a huge data set. And the reason that I'm only finishing my analysis on it now is that we had a huge collaboration, big collaboration, I guess, for us, different groups of scientists, and everyone had to process their own data. And students had to learn how to do things. And it's taken 1.5 years, 2 years for everybody's data to come together in a format that everybody else can understand. So what I have to do now is look at my bit of the data in the context of everybody else's. And it's taken so long. 2 years seems like such a long time. But a lot of things had to be built and analysed and designed and fixed in order to get to that point. So that will be a nice, to finally see what the complete picture is of, the ocean state that we saw. That's exciting. And then, of course, there's lots of ideas. So I'm excited about the new ideas that I will hopefully be able to study, proposals I'd like to write. There's a lot of work in the Arctic right now, but the Arctic is changing faster than any other part of the planet. And so understanding what happens as the sea ice retreats and as the weather patterns change, that's, there's always the next thing. That's the frustration. I haven't finished the previous thing, and I'm already getting slightly too excited by the next thing. That's the way it goes.
Well, good luck with finishing up your study. Thank you very much for talking to me. And we look forward to hearing what happens next with you.
Brilliant. Thank you.
So I'm here with Clive Thompson, who is a journalist who writes about technology for the New York Times Magazine and Wired, and he's the author of Smarter Than You Think, and is also working on a new book about how programmers think. Welcome, Clive.
Hi.
Now, we've been having a quick chat about women in STEM, and you have one woman in particular that you're a bit of a fan of.
Yes, it's Ursula Franklin. She is a scientist at the University of Toronto, a metallurgist, and she changed my life, actually. A conversation with her and reading her book in 1990, The Real World of Technology, that changed my life.
That's a huge impact for someone to have. It's not often people say, a book changed my life, and say it with such conviction. How did that happen?
Well, what happened was that I grew up as sort of a nerd child of the 1970s and 80s. One of the ones that learned a bit of basic programming on, Commodore 64s, the VIC-20s. But when I went to university, I knew that I wanted to be a journalist. And so I didn't study science or technology or whatnot. I studied English, political science. I wanted a sort of a general interest BA, right? I thought, and I thought that, serious journalists wrote about politics, right? So I was trying to prepare myself to write about that. And, but I remained throughout my degree, I remained sort of a background nerd. Like for my pleasure reading, I mostly read science fiction and, popular physics, and I kept on top of what was happening with computers, and BBSs and the sort of pre-internet. And I remained fascinated with that stuff, but there was part of me that thought, no, what journalists write about is, politics, the important things. So towards the end of my degree, literally in the last year, I picked up a copy of The Real World of Technology, which is a collection of lectures. They're called the Massey Lectures, and they're broadcast every year. The Canadian Broadcasting Corporation in Toronto picks someone to deliver a series of lectures, and then they publish it as a book. In 1989, it had been Ursula Franklin, and she had picked as her subject technology and its impact on everyday life. I picked up the book, and it was absolutely amazing. What she did in that book is really talk about the ways in which technology affects the social dynamics and political warp and woof of everyday reality. Like, for example, she sort of, just as a simple little thing, she was talking about the evolution of door locking technology, so for decades, for centuries, we have these metal keys, and they're a technology that says, okay, you can or cannot go in or out of that room. That's what the key does. That's what's built into that technology. But beginning in the 1980s, when she wrote this book, you're beginning to see credit card swipe technologies. And so the upside of these for people that own buildings is that it's quicker and easier to reissue a key, so it's cheaper. But also they begin to insert command and control technologies, because now the person who owns the lock that you swipe it into has data on who went in and out of that room. So they can now sort of observe in a panopticon-like way what's going on in the world, what's going on in their building. They know a lot more about you and what you're doing. They can also, on the fly, decide not to let you in a room. They can change whether or not that lock works with your card. And so it's not just a new type of key. The technology changes the social and political fabric of reality. So when I read this book, I had never really thought about technology that way. And I was completely ignorant of the decades and decades and centuries of social thinkers writing about this, But Ursula Franklin, was very well read in the tradition of people like Lewis Mumford or Jacques Ellul, thinking about the political and social implications of technology. But this was the first time I'd got it. And she's such a wonderful writer and speaker. And she did this so clearly that I realized that all the things that I was innately interested in, like the nerdy stuff about technology, I could completely unify that with the idea that I really wanted to write about politics and society and everyday life, and that I could bring these two together because technology was becoming more woven in a way. Computer technology was becoming more woven into the fabric of everyday life. And this book essentially showed the way And so from that moment onwards, I decided that I was going to devote myself to journalism that looked exactly at that intersection of politics and culture and society and technology. And I've been doing that now for 25 years.
That is fantastic. And I think I can see exactly why her book would have that kind of an impact, because even just reading her Wikipedia page, it talks about the difference that she draws between work-related technology and control-related technology.
That's right. Yeah. One of her main points was that one of the things that computers do is because they allow for monitoring and collection of data in a centralized way, they are frequently used to increase control. So one of her in her first sort of lecture, she talks about the transition from typewriters to word processors, and she says, okay, so typewriters, they had some effects on the way we write. They changed a little bit the way we write. Word processors, definitely changed the way we write. They made it possible to do revisions of a type that weren't possible before. But they also added the ability of a remote authority to now observe what you're doing. And so corporations are now able to know, down to the word, what the output of workers were. In fact, I experienced that because a few summers before I wrote that book, I worked in the classified department of the Toronto Star, and we worked on, sort of computer terminals that were rudimentarily networked. So my boss, the boss of everyone on that floor, and there was like probably 50 of us typing up classifieds and selling them all day long, could know exactly how much work I'd done that day, that minute, that hour, because it was all centralized. And in fact, they would call me and we would talk about that. So, so her whole point is that, computer technology brings with it not just interesting new abilities, which can be very, very cool, but control, political control. And
she makes the fascinating point that actually women are often the victims of that control.
Absolutely. Yeah. She was a very, very terrific feminist, a Quaker, a pacifist, and a feminist. She saw those things, all as one of the whole. And yeah, I mean, she points out that a lot of technologies that started out as being quite creative and interesting for women, like the sewing machine, which allowed women in their households to make things that were very useful for them, to empower themselves in interesting ways. Once sort of capitalism got its hands on it, turned it into the sweatshop, sort of 100 women working for very little money and doing incredibly dull piecework instead of creative work. So yeah, her career is really one of being an absolute pioneer in science. She's old enough that, she got her start in science working in government labs in the 40s. And then, of course, after the 40s, after the war was over, all the men came back from the war, and they began to supplant all the women who'd been given these opportunities. And she saw that happen. She was one of the few that kind of didn't get drummed out of the labs in the 50s and 60s. And she went on to really decide that one of her life's missions was going to be to agitate for the position of women inside science and technology. And she's been such an absolute pole star for that work that the Canadian government's given her several honors for work in that regard now.
Which makes me feel somewhat ashamed, actually, that I'd not heard of her until you mentioned her. But she seems like someone whose work anybody in technology, whether you're a programmer or a designer or whether you're a journalist, that we all really need to know Ursula Franklin's story.
Yeah, absolutely. And I would encourage anyone who's interested in these political and social implications of technology to pick up that book, The Real World of Technology. It's short. You can read it in an evening. And yet she wrote it in 1989. She gave those lectures in 1989. And yet you really feel that she was just several decades ahead of her time. She has this wonderful line in the beginning of her lecture. She says, technology has built the house in which we all live. Today there is hardly any human activity that does not occur within this house. Now, in 1989, I think it was probably harder to see that. But now in the world of like Facebook, you immediately see that. Facebook has built this house in which we live. And so what they do impacts the way we live. So in some respects, I mean, the book did, she had a great blast impact in Canada when it was printed, but you can read it now and get even more out of it because she was so far ahead of her time.
Is there anyone you think who's really sort of continuing this line of thinking and the work that Franklin's done?
Yeah, very many. In fact, one of the things that's interesting about my line of work is, so I'm a journalist and I write about social, political implications of technology. And you'd probably have noticed a trend if you started reading, my features and my columns 15 years ago, which is that over and over again, a lot of the people that I was quoting, the people who study this stuff, are women. For whatever reasons, there are an enormous amount of very prominent women examining this question of the social impact of technology. So people like Zeynep Tufekci, who is a sociologist who studies this stuff. I cottoned on to her work early on in my work about social networks. She's a fabulous thinker. Dana Boyd, an absolutely pioneering thinker, and a person who's researched probably better than anyone else the effect of technology on the lives of young people. Some of the other folks, it's really funny how when you think of people now, you often think of their Twitter name first. I thought of Feral Data on Twitter, Genevieve Bell. She works for Intel, and she basically has for a long time now done amazing work on how people use technologies in their everyday lives, and she travels around the world investigating this stuff. Or Mimi Ito, who did pioneering work back in the 90s, looking at how mobile phones were changing social life in Japan, and has now moved on to looking at the impact of technology on education. So these are just some of the names, but I could literally give you a list of 20 or 30 of them, of these people who over and over and over again have, I think, been carrying on exactly this work. I mean, there's certainly men doing it too. There's plenty of men doing it too. But what's striking to me is how many women are the real intellectual leaders in this field of looking at social and political implications of technology.
My suspicion would be that is because women are often much more deeply and profoundly affected by these changes. But also, I think we perhaps have a slightly different view of what technology is. There was a great chapter that Helen Czerski wrote for our book, Passion for Science, actually kind of arguing that the sewing machine is technology, that we need to broaden our idea of what technology is. It's not just a phone. It's not just a computer. That as soon as you start doing any sort of complex task, like with tailoring, you're basically creating a three-dimensional object from a two-dimensional object, and that actually is quite complicated.
Oh my goodness, yes, yeah. I mean, like the entire history, women's interactions with technology have been unbelievably interesting over the last couple of centuries, and one of the things I think that you're quite right has made maybe part of the reason that there's so many women involved in understanding and probing the implications of technologies in everyday life is that they've often been women, and particularly housewives in a very funny way, are often used as the examples of or the sort of targets of a new quote unquote labor saving technology that turns out to be anything but, right? That was the whole thrust of the post-war expansion of home devices. Like, we're going to create all these technologies that will supposedly free housewives from labor, ranging from stoves to refrigerators to ovens to whatnots. But all it really did, and critical thinkers of the 60s, 70s, 80s noticed this, was it created new forms of labor, right? And raised the bar of what you were supposed to get done. And so feminist thought has long been, in a very intelligent way, looking at these paradoxes and unintended consequences of technology.
It is absolutely fascinating. This is a conversation I think we could have for several hours. But thank you so much, Clive. It's been an absolute pleasure talking to you.
I had a great time. Thanks again.
My thanks to Helen and Clive for some fascinating conversations. You can find out more about them and our new podcast on our website at findingada.com/podcast. Thanks again to our sponsor, Arm. You can learn more about Arm on their website at arm.com, and you can follow them on Twitter at armholdings. So join us next month when I'll be talking to science presenter Fran Scott about her work designing science demos for TV, and Maya Weinstock, Deputy Editor at MIT News, about the Queen of Nuclear Research, Chien-Shiung Wu. Don't forget, you can follow us on Twitter @FindingAda, and we're on Facebook, Pinterest and Redbubble as Ada Lovelace Day. And all our links are in the show notes. If you'd like to send us feedback about the show, or if you'd like to take part, you can email me at sue@findingada.com. See you next month!